Hello doctor, this is group 3. So what is point defect? Point defect is the type of imperfection in atomic structure of a material that occurs at or around a single point in the crystal lattice. This defect disrupts the regular arrangement of the atoms and can affect the material properties such as strength, conductivity, and optical behavior. Moving on to vacancy defect. So a vacancy occurs when an atom is missing from its regular lattice position, leaving an empty space. This atom can leave the lattice structure sites due to high temperature, irradiation, or other energetic processes. As you can see in the slide, that's a visual representation of what a vacancy looks like. So what is the effect of vacancy? First of all, it reduces the density of the material because there are fewer atoms in the structure. So this can increase diffusion since atoms around the vacancy have more space to move around. This leads to weakens the material by disrupting the atomic arrangements. And for example, in metals, vacancies are common at high temperatures as atoms move around.
Thank you for that explanation. Now, let's move on to interstitial defect. Interstitial defect occurs when an extra atom is squeezed into a position between the regular lattice sites, not a regular sites in the lattice, which is the extra atom is not supposed to be there or fit in there. This defect can happen naturally in some materials or by adding foreign atoms that are small enough to fit between the lattice. And now, the effect of interstitial. Firstly, it increases the density of the material because more atoms are packed into the structure. Second, creates stress in the lattice since the extra atom disrupt the regular spacing. And third is also can block dislocation movement, strengthening the material in some cases. For example, about the effect of interstitial is in steel, small carbon atoms fit into interstitial spaces between the iron atoms. As the result, it is increasing hardness. Overall, let's take a look at the key comparison between vacancy defect and interstitial defect. For nature, vacancy is missing atom in the lattice, meanwhile interstitial have an extra atom in between lattice sites. For density, the missing atom and empty space for vacancy defect may it decrease material density. Meanwhile, extra atom that squeeze into position between the regular lattice sites in interstitial defect may it increase material density. For lattice stress, vacancy has minimal lattice stress, but interstitial has high lattice stress due to its extra atom. Last but not least, effect on strength. Vacancy mostly weakens material, such as make it soft and easy to bend. Meanwhile, interstitial may strengthen material, make it hard and can use for the long-term period. Let's conclude the topic of point defect. Now, we will move on to a new topic.
So now we are moving on to line defect, which is edge dislocation and screw dislocation. So what is dislocation? A dislocation is a linear defect, meaning a line-like irregularity where the atoms are arranged differently compared to the rest of the crystal. It is creating a localized region of strain and acting as a boundary between a slip and unslip region of the material. And we can see the example of the dislocation process at the left side of the slide. The left one is the edge dislocation and the right one is the example of screw dislocation. Okay, now we are moving on to edge dislocation. The edge dislocation is a line defect in a crystal structure that occurs when an extra half plane of atoms is inserted into the crystal lattice. As you can see in the figure, we can see that there are an extra half plane of atoms at the upper part of the crystal lattice that makes the shape looks like more wider than the bottom part of the crystal lattice. And the characteristic of the edge dislocation is dislocation line is perpendicular to the Burgers vector, and it creates the tensile stress above and compressive stress at below the slip plane. And the movement of the edge dislocations process, it is caused by shear stress. The edge dislocations moves by atoms pushing the extra plane along the slip plane. The slip plane is located at the middle of the crystal lattice.
Okay, so next I will go through for the screw dislocation. So for the definition,
Screw dislocation is a type of dislocation in which the Berger vector is parallel to the dislocation line, resulting in straight line defect in the crystal structure. Okay, so for the characteristic, dislocation line is parallel to the Berger vector, and next is cause a helical distortion in the crystal. So basically, helical distortion is atomic planes that are twisted into spiral shape rather than remaining flat. For the movement, it moves through the rearrangement of atoms around the screw axis under shear stress. So next is the comparison of edge and screw dislocation. So the first one is dislocation line. For the edge dislocation, it is perpendicular to Berger vector, while the screw dislocation is parallel to Berger vector. For the second one is lattice distortion. For the edge dislocation, it is extra half plane of atoms, while the screw dislocation is spiral realms of atom. So the third one is movement. For the edge dislocation, it is by gliding, while the screw dislocation is by shearing. The fourth one is the stress field. For the edge dislocation, it is tensile or compressive regions, while the screw dislocation is helical distortion. For the analogy, the edge dislocation is like an extra page in a book, while the screw dislocation is like a twisted paper stack. Last but not least is the importance of dislocation. So it is enable plastic deformation in materials. It is influence material properties like strength and ductility. For the strength, the more dislocation, it is more higher the strength. For the ductility, facilitates movement, allowing materials to deform. Thank you.